In the Eastern Mediterranean, Cyprus is located at a unique pollution crossroad. Air masses from Europe, Africa, and Asia bring a complex mix of atmospheric pollutants influencing the local air quality. However, distinguishing between the pollutants that are produced locally and those transported from afar remains a significant challenge. To address this issue, local public bodies and research institutions have united to, as implied by the project's acronym, assess the climate change effects of pollution transport in Cyprus. Thanks to the funding from the Norwegian Financial Mechanism and the Republic of Cyprus, we were able to develop cutting-edge atmospheric measurements aiming to generate new data that will be used to improve regional computer-based modeling. The air quality in Cyprus is monitored by the Department of Labour Inspection since 2006. In total, 9 air quality monitoring stations are distributed across the island, targeting different pollution source categories such as traffic, urban, industrial, and background. While this network offers the much-needed fundamental information on air quality, more sophisticated tools are needed to address this specific challenge. Therefore, the Climate and Atmosphere Research Center of the Cyprus Institute has installed and operated state-of-the-art instrumentation in 2 diverse sites, one urban and one remote, and developed a new low-cost sensor network across the city of Nicosia. By analyzing these new datasets, we found that while the winter air quality is largely affected by local emissions, Cyprus is heavily impacted by transported air pollution. In fact, the local atmospheric composition during summer and autumn is mainly regulated by imported pollution.
To accurately track the pollution transport, the examination of the atmospheric structure and the vertical profile of the atmospheric parameter is crucial. At the Eratosthenis Center of Excellence and the Cyprus University of Technology, state-of-the-art remote sensing techniques are used to monitor the aerosols and the atmospheric processings in a coastal area of Cyprus. During the ACCEPT project, an advanced LiDAR system has been used to characterize numerous Sahara and Middle East dust events, to identify smoke plumes from wildfires and biomass burning activities, as well as from Etna's volcano eruption. These observations highlight the important role of vertical profiling in understanding how different types of pollution move and interact through the atmosphere.
Beyond ground-based measurements, 3-dimensional observations are necessary for understanding pollution transport. The Unmanned System Research Laboratory of the Cyprus Institute has equipped its drones with novel sensors and developed a balloon-assisted system for high-altitude measurements aiming to reach the tropopause. These advancements have uncovered stratospheric intrusions of ozone as an additional natural source of transported pollution and helped characterizing the vertical profiles of dust and smoke transport events. With these observations, the ACCEPT project has compiled Cyprus' most detailed atmospheric pollution dataset to date, providing a new understanding about the air we breathe.
All these new observations were used to improve our Earth system models and provide reliable atmospheric composition and climate projections. This is accomplished by explicitly accounting for the processes that determine the life cycle of aerosols and oxidants, and interactively computing their impacts on air quality and climate. We have also performed projections of the future changes in atmospheric concentrations of desert dust based on climate change pathways. We thus adhere to the IPCC recommendation for accounting climate change and air quality feedbacks. The ACCEPT air quality forecast products are targeted to the public at large, and in particular to the most vulnerable populations.
The processes that are described in our Earth system climate models are deeply influenced by feedbacks imposed by climate change. During the ACCEPT project, we analyzed a large ensemble of climate simulations to understand how the current dynamics might change over time. We found that the island is getting warmer than the global average, especially in summer and spring, while rainfall has declined mostly during autumn. Our future projections show that temperature will further increase throughout the island, while areas near the coast and around Nicosia could see less rain, pointing to a drier future. These shifts in climate will have direct implications for ecosystem and every socioeconomic activity on the island and can influence the regional pollution transport mechanism.
In the concluding phase of the ACCEPT project, we focused on the socioeconomic risks that are posed by both air pollution and climate change. We engaged in extensive discussions with stakeholders, including public authorities and businesses, aiming to understand their needs regarding the implementation of the newest EU energy and climate policies, and identify the challenges that arise on social equity and business competitiveness. In collaboration with the European University of Cyprus, we've highlighted the health risks from rising levels of ozone and particulate matter, noting that these are largely influenced by pollution transport. Additionally, our findings indicate that climate change could amplify the risks such as invasive species, wildfires, and extreme weather, posing further threats to public health and safety.
In conclusion, the ACCEPT project emphasized the pressing need for science-based strategies that address the complex interplay between air pollution, climate change, and health. By providing a detailed understanding of these dynamics, ACCEPT has set the foundation for informed policy making and effective mitigation efforts, aiming for a healthier, more resilient Cyprus in connection with policymakers.